hopefully. There we go. All right. Looks like the chat has slowed down a little bit, so I'm gonna hope that means folks have more or less made it in. So thank you everyone for joining us this morning. I think everyone's in time zones where it's still morning. My name is Saber Comet. You've seen my name at the end of numerous emails. And just want to thank you for joining our second ever Beaver Dam Analogs workshop. This is a new format for us. So last year when we tried this for the first time, we did everything in person, and it was just a lot of classroom work and then going immediately out into the field. So now to help accessibility and to save some brain power, we have split this up into the classroom version is we're doing this virtually, and then those of you that can join us will be coming out to South Slough to do 1 to 3 field days next week. So if you are participating in the field days, if you're not, please make sure to ask questions. We have the specialists here. We will be doing a break every day about in the middle. And just remember that each day is different. So if you can't make, tomorrow as well, just make sure to view that before the field days occur. So just a little bit about our organization. We are, Alice and I work, and as well as several of the interns on the call, work at South Slough National Estuarine Research Reserve, which is one of 30 reserves in the U.S. coastal states, territories, and Great Lakes areas, where we balance education, research, stewardship, and with heavy partnerships from all over. We are a NOAA state partnership. So we are within the Oregon Department of State Lands, but we also have funding and guidance from NOAA. The workshop is sponsored by my program, the Coastal Training Program, and we're in charge of doing knowledge transfer events for decision makers, which everyone on this call is a decision maker. And with that, I will hand it over to our stewardship coordinator, Alice Yates.
Thank you. I like being described as a decision maker because I feel like sometimes it's hard to make decisions and it's like I'm a decision maker. Anyway, I'm Alice Yates. I'm the stewardship coordinator here at South Slough Reserve. Among many, roles that I have at the reserve, one of which is coordinating and developing restoration projects within the reserve, and then advising and assisting and with other restoration projects in our greater service area as well. So I'm going to talk a little bit about the larger project that we're doing here at the South Slough Reserve, and then kind of narrow it down onto BDAs. But I just wanted to welcome everyone to the call first, and welcome our speakers to the call. And Saber, would you like to just point out who the speakers are and a quick introduction, or they can introduce themselves as well just before we get started?
Damien, do you want to start? These are our two fearless leaders as far as the workshop goes.
Thanks. Good morning, everybody. I'm Damien Ciotti with the U.S. Fish and Wildlife Service Coastal Program. I work mostly in California, in the Outer Coast and San Francisco Bay Area. And yeah, I've been working with beaver, working with process-based restoration approaches for probably about almost 12, 13 years now, and look forward to getting out in the field and building some structures and meeting all of you. Thanks.
Great. And Saber, do we have any other speakers on the call at the moment? I haven't looked at the agenda. I know other people are speaking as well.
I don't see Emily or Brandy on yet.
No, I think they're going to join us later, so we'll introduce them when they when their PowerPoints come up.
Perfect.
Yeah.
I'll share my screen then. Let's see. Okay, are we seeing that correctly?
Yes.
Perfect. And I said it earlier on, but feel free to leave your camera on if you're inclined to do so. I love seeing people's faces and just sort of gauging if people are understanding what I'm saying, if people need me to slow down or speed up or are feeling bored or whatever else. Hey, Ashton, thanks for joining. But you're also welcome to have your camera off. I know that sometimes you're multitasking and do other things as well. So I'm going to sort of start large and talk about the Wasson Creek Watershed Restoration Ridgetops to Estuary Restoration Project. And so the BDA component of this is a small area within this greater watershed scale restoration project, but I wanted to give you all just sort of an overview of where this work fits in before we sort of dive deep into BDAs throughout the day. So I'm the project lead on this. However, we have a really large advisory team, and I like to do my thank yous right up front because this team is just incredible and they have just really guided this project for many, many years now, and it's been a huge group effort and a lot of people have been involved in this project. So thank you to everyone involved. Just an overview of today's presentation. So it looks like I'm scheduled to talk for the next half an hour. Feel free to sort of leave questions to the end, or you can put them in the chat and we'll kind of get to them as we go. Interrupt me if there's anything, really wrong or, that needs to be drawn attention to. So I'm going to talk a little bit about our funding for the project, what this large watershed scale restoration project is, and then the BDA component. I'm going to talk about the goals of our BDAs, our timeline that we've been working on, research and monitoring questions and what we're doing, permitting and environmental compliance, and then a little bit of what to expect during field days. I know not everyone on this call can make the field days, but I decided to put these in here because it's also kind of what to expect if you're installing BDAs yourself. And then we'll have some time for questions before going to a break. So in terms of funding, the reason that we could do a really large watershed scale restoration project is because of the NERS, National Estuarine Research Reserve System's Habitat Protection and Restoration funding, which was made possible by the Bipartisan Infrastructure Law. We're also part of the Coos Basin Coho Partnership, and through a focused investment partnership with the Oregon, OWEB, Oregon Watershed Enhancement Board, sorry, all these acronyms, we received some funding from them. Also with the U.S. Fish and Wildlife Service Coastal Program and the Coquel Tribe, Indian Tribe Community Funds. So what is a Ridgetops to Estuary Restoration Project? So you can see the outline of this watershed here, and you can see that the forests are in different stages of clear cutting and regrowth, and some of the wetland lower areas here. So I'll be kind of pointing out what we're doing in each of these and what the issues are. So where is it? So we are down here on the southern Oregon coast. The brown outline on this map is the South Sioux watershed. The green is our boundary of our managed lands. This is actually a bit of an older map. We've expanded a little bit since then. And then the orange down here is the Wasson Creek watershed. So we're at the southern extent of the South Sioux Reserve boundary, and it's just near head of tide. So we are just tidal in this lower section of the project area. So why does it need restoration? So the drainage here on the top, you can see here in the early 1900s, there was agriculture in this area. And so as this process to get drier land to raise cattle and grow crops and all of that, important stuff for subsistence living in this area, they drained these wetlands, and the channel now runs along the edge of the floodplain there. And so this whole area here was dried out essentially and no longer functioning as a wetland, which is really, you know, important for off-channel habitat for coho salmon and many other different species, including lamprey and songbirds and you name it, they like it. This drainage just south is actually the Anderson drainage, and that was restored 20 years ago. And so if you come to the workshop, we'll be able to go over there and see some really fantastic success that we're having in that restoration project and some really good beaver activity. So consequently, we have these sort of deep incised ditches on the side of the channel here, and we have really thick reed canary grass dominating, which is an invasive species. It's just dominating that floodplain and very little use and benefit of having reed canary in there. So that's why we're doing the restoration work. This is a watershed scale restoration project. I'm not going to focus too much on the uplands, but you can see here that our forests in this area are really dense trees, almost monocultures for the most part in here, very unhealthy trees. And so I just wanted to mainly mention this to give you a context of this sort of ridgetops to estuary work that we're doing, but also that we're pulling some of the material from these areas to use in our Beaver Dam analogs. So our big restoration objectives are expanding tidal forested swamps. So in Oregon, we've lost over 95% of this habitat type, and it's really important for, as I said, coho and other species. Beaver use these areas as well, and they're really high in blue carbon storage. Also re-establish wetland stream complexes throughout that area of reed canary grass dominated where it's disconnected floodplain. We want to re-establish these wetland systems, and then in our uplands create these diverse and complex forest habitats. So within these sort of broader goals, we have a lot of sort of additional goals that are sort of wrapped up in that, like increasing cultural resources and use, you know, increasing beaver activity through re-establishing food plants for them, native plant abundance and diversity, habitat for salmon and lamprey and other fish species and bird species. And then there's also the endangered marbled murrelet that is an ocean going bird, but it nests in old forest trees, so old growth forests, and so part of our forestry actions are to enable those sort of dense trees to grow in and establish these suitable habitats. So how are we restoring the valley? We're using many different restoration techniques. So we have all these different goals, but we also have unique situations in different areas. So there's different sort of hydrological situations going in some areas where it's wetter and other areas where it's drier. We've got just a lot of different, like the spruce, the tidal forested swamp is just in the tidal area. It's not further up the valley. So we have a lot of goals. We have a lot of different situations. So we're using different restoration techniques. So just going through those, we're building what's called nurse cribs to plant tidal forested swamp areas. And so this is using some of that thinning project that we're doing in the uplands and building these, then mimicking nurse logs. We're doing a lot of mimicking in this project. We're mimicking beaver dams, we're mimicking nurse logs. We're just trying to increase these opportunities for, you know, the plants and animals to re-establish themselves. So we're using, for the larger project area, we're using what's called stage 0 restoration technique, or restoring to a stage 0 conditions. So this is actually using heavy machinery to scrape out that reed canary grass, get below the root zone and get it out of the system, and then grade the valley to a 1% grade line and place a lot of large wood on it. And this re-establishes complex flow pathways in our floodplain area. this is just some fish salvage work that we were doing as part of that project. We're working with our tribal partners to restore cultural resources in the area. Like I said, it's dominated by reed canary grass. Up in the uplands, there's monocultures of tree communities. And so this is the ancestral lands of the Melik Kuz people, and many of these people are currently enrolled in the confederated tribes of the Kuzlaw, Umpqua, and Sayuslaw Indians, the Kukwel Indian tribe, and the confederated tribes of the Siletz Indians. And so part of this project, this larger watershed project, is to really enhance these cultural interactions with lands and waters. And then in the uplands, like I said, we are adding complexity. So we're using what's called a variable density thinning prescription to restore forest complexity. And then what you're all here for is the Beaver Dam Analogs. And so there's certain areas of that lowlands current incised ditch area that we won't be filling in as part of the larger Stage 0 restoration project. And there's areas that we need to use these beaver dam structures to alter the hydrology and the connection with the floodplain, and also to try and shallow up those deep ditches. We are a research reserve, and so we are doing a lot of monitoring to look at our success, and Jenny Schmidt is our watershed monitoring coordinator, and I'm not going to go through all of this different types of monitoring that we're doing, and I'll sort of skip to the BDA monitoring in a little bit. But I just wanted to give you a broad picture view of what we're looking at in the valley. So let's talk about BDAs. So this is our watershed again, here in the yellow outline. We have one main large valley and then a smaller upper valley, and there's a constriction here at this, what's called the upper complex. So above this constriction, the stream channel was never ditched, and it's braided and it's in reasonably good health. It does still have some reed canary grass, and we're using overplanting with willows and other shrub species to try and shade out the reed canary in that area. And then we have, so down here on the right hand side is the confluence with Winchester Creek. So Winchester Creek is the main tributary going into South Slough Estuary, and the tidal waters extend just past this Wasson Creek area here, the confluence. And so this lower complex area is tidally influenced with fresh tides. And so in 2023, Jared and Damien came down to run a workshop with Sabre organizing that, and we had a really great success of folks helping out in building Beaver Dam Analogs here. And then I'm going to talk about our timeline and this year in a second, but the upper complex here hasn't been installed yet, so that will be installed later in 2024. So what are our project goals? So specifically now we're talking about BDAs. The project goals for 2023 in that lower complex were really to trap the sediments in the streams and regrade the channel. We didn't want the channel to connect with the floodplain at this point, and that was because later on this year we are going to get large equipment out here and doing that larger restoration work, and so we didn't want to connect the stream channel onto the floodplain and make that area really hard to work in and wet. We needed to keep it kind of dry. So the first year we just built shallow BDAs to trap those sediments and just try and shallow up that channel a bit. So in phase 2, it's just one of the same project goals is we want to reinstall or install some secondary BDAs in that lower complex to again shallow up that stream, to regrade it. We want to be repairing the damage from winter high flows in those original BDAs, and then connecting the floodplain to the stream for the 2024-25 winter high flow period. So we're in low flow times at the moment, but it is tidal, so we're still balancing this relationship between getting the valley, keeping the valley dry for our larger restoration work, and then but also wanting to connect it with after that work. We will also be installing the upper complex, and the main goals of the upper complex is really to connect the floodplain. And so once all of that earth moving work is done and we're releasing the flow back onto the channel, we really need that upper complex to disperse the water across the valley floor for us and try and pop that water out of the ditching and current channels up there. So why repair? So the image on the left here with the mud packed in here was just after we completed the BDAs in 2023, and you can see that after that high winter flow months, we saw a lot of damage to that BDA, and this is something that I believe we'll be talking about throughout this sort of webinar process. It's about what we're looking for in a BDA, and so you'll know what's wrong with this picture, I guess, by the end of this webinar series. And so we will need to be doing some repairing for that to function properly as well. So in terms of our timeline, so this project there's been a long process of planning, funding, permitting, pre-restoration monitoring going on. Last year, we built that lower BDA complex. Next week, we're going to have many of you come join us and build the second lot of BDAs in that lower complex, as well as repairing last year's BDAs. And then in this period, immediately after, we're going to be completing our stage 0 restoration work. And in September, we'll be going back out there to build the upper complex of BDAs. And like I said, once that stage 0 restoration grading has happened, we want that flow to spread out across the floodplain and re-wet that floodplain area. And so that's where those upper complex will be really important. And then there's going to be, several years of monitoring, assessing success, building the second phase in the upper complex, and continuing to do this until we're kind of happy with how it's functioning, and hopefully beavers are moving in and deciding if they want to keep them or take them out, and we'll kind of work with them for the rest of the time. So in terms of our research and monitoring, we're really interested in how BDAs change groundwater hydrology adjacent to the current stream, as well as stream flow and evolution of channel morphology. So we kind of hypothesize that the water table levels will increase, potentially diminishing with lateral distance from the stream, so the further you get away from the stream, and then stream flow rates will also decrease with the BDA installation. And so we're monitoring this with groundwater wells adjacent to the stream at different distances along the BDA complex, and with groundwater, with loggers, water level loggers in them. And then we're also doing cross-sectional discharge measurements with a handheld flow meter. And so I'll have that out during our workshop so people can have a play around with that and use it to see how the flow is changing throughout the workshop period. And then we use RTK and leveling surveys to look at how that in-stream channel elevation profile is changing and cross-sections are changing. So the fun stuff, the permitting, environmental compliance, and all of that is a really important stage. Essentially, I, as project manager, kind of hand this off to other people to do. So I'm going to do my best in explaining what the permitting requires, and I know that there's actually a few people on this call that do permitting in our department, and so feel free to step in and chime in on that as well. So this is federal funds, and so as part of the federal funding, we go through an environmental compliance review, and this is done by NOAA, our federal partner, and this involves a whole suite of communications and checking in with US Fish and Wildlife Service. All of the tribes in Oregon and Northern California are notified of the project, and there's a whole suite of different environmental compliance reviews that they do as part of that. We also work closely, so there's the required, notification to the tribes, but we also work with our tribal historic preservation officers, or THPO. We have three, as I mentioned before, 3 tribes whose ancestral lands overlap on South Sioux Reserve. And so we work with tribal THPO from each of those 3 reserves. And by doing this ahead of time, we're looking to reduce the likelihood of unearthing cultural resources in our area. But we also build an inadvertent discovery plan. So if we were to unearth something or discover something, we would be able to respond really quickly. My recommendation, if you are applying for funding to do restoration work of any kind or any sort of earth-moving work, is to put some funds in there, if possible, to pay an archaeological firm to help with the monitoring and an inadvertent discovery. The tribes are really maxed out with capacity. There's a lot of great restoration work being done in our area and beyond. And so, this summer, I know that they're really stretched trying to have monitors on site. And so just having that extra support for them is a recommendation that I've found really helpful. So permitting, let's see. So the BDA work was permitted through the Regional General Permit for ACO. And the general permit for Oregon Department of State Lands. So these permits are issued to BLM, Bureau of Land Management, and the Forest Service. So we're working with BLM to run our permits through. And then, so as part of that, BLM has been handling all of this permitting and submitting any pre-project notifications and receiving verifications and all that kind of stuff. So like I said, I'm kind of once removed from this process and just sort of feed in information, and they are going through the processes. But as part of the ACO requirements, there's a wetland delineation that needs to be done, and so we completed that at South Sioux in assistance with Oregon Department of Fish and Wildlife. Other requirements include tribal notification letters and cultural clearances for Section 106 of the National Historic Preservation Act. The ACO permit also has a consistency determination from the Oregon Coastal Management Program within the Department of Land Conservation and Development for the Coastal Zone Management Act. So there's a lot of these kind of processes that are involved in each of the steps of submitting these permits. They also require Clean Water Act, Section 104, water quality certification from the Oregon Department of Environmental Quality, and go through Environmental Species Act and compliance. So working with the Forest Service, working with US Fish and Wildlife Service, aquatic restoration, biological opinion, and the NMFS, which is NMFS, aquatic restoration biological opinion. So those are 2 different processes that are known jointly as ARBO 2. And BLM submitted this whole process for us through the ARBO 2 biological opinions. Because this work is not they call it private land, it's not federal land, we also require a WIDEN form, which is required by Department of State Lands, and it's a sign-off from the county to show compliance with county laws, land use laws. And a part of that county land use review is the determination if the project is within FEMA floodplain area, which the Wasson project is. And then, so we had a process by which there was stamped for floodplain certification, which is verifying that the project would not result in a net rise in stream elevation. You know, making sure that we're not contributing to flooding in the area. And so the county, you know, accepted that part of this project wasn't going to have a detrimental effect on it. So the permitting stuff is really, there's a lot of moving pieces to it, but it sort of boils down to, for our area at least, is that BLM and US Forest Service are the two entities in our area that we can go to run through these processes. And then, so for us in this particular area, our in-water work period actually starts July 1st. And so in order to do the workshop earlier than July 1st, we had to apply for a variance. And the argument for doing it before the July 1st was that we really wanted to track the sediments during the earth moving phase. So we needed to get these BDAs in before we went and did that large scale earth moving project, because we just saw that as a beneficial way of making sure sediments aren't moving into the Winchester Creek area. And then we also wanted to install them in order to get the channel flow as much as possible to track those sediments and do the work that the BDAs were designed to do for as long as possible. And so as part of that other work, we'll be filling in the channel upstream. And so we wanted to make sure that we had some flow to work to get through this process. So what to expect during field days, or if you're not coming to our workshop, what to expect if you're kind of installing it. And like I said, Damien and other speakers are going to really talk about BDAs more in general and specifics, but just a few things, I guess. So we'll be doing some willow cutting. We'll be working in areas of dense willow to get materials for the BDAs. We'll be working in streams, pushing these cuttings into the banks and packing them down and using mud to pack them down. And again, you're going to hear about the process of why we're doing this in a little bit. We use a post driver to drive in posts to hold the structure in place. You will get muddy and wet. For those coming to the workshop, we will have waders and all of the gloves and equipment that you need to be on site. We will be taking some breaks, and last year people found the Reed Canary grass kind of a nice bed. And there will be lunch and snacks provided during the workshop days. And just wanted to sort of loop back to Jared and Damien, who you'll hear from in the workshop today, as well as if you come on site. They've just been really fantastic in helping us with our planning and installing our BDAs and educating staff here at the South Sioux about what they are and the purpose for them. So I really appreciate their involvement in this project, as well as the workshops that we're offering. And I think that is it from me, so we can kind of move to questions and discussions. And we have a bit of time, I think, before our break.
So we did get 2 comments from 2 of the very knowledgeable permitters on the call in the chat. One from Melody Rodenko and one from Charles Barr. And I'll make sure that both the comment and the link that they attached make it into our resources packet. So thank you for that. Alice, do you want to make any notes of what is going to be expected during the field days before we jump into the questions?
Anything in particular that you're thinking about?
We can wait until later too.
Okay.
Yeah, so I'll go ahead and open up the floor if you could. We have over 20 people on here, so if you have any questions, can you either put into the chat or raise your hand and I'll call on you?
Yeah, I appreciate the DSL permitting team for correcting any or clarifying any of the process that I glossed over. Like I said, it's not really part of what I've been involved in, but if they have anything that additionally you want to say as well about permitting, feel free to chime in. Yeah, we've got one hand raised. Go ahead.
Yeah, hi folks. My name's Mac Barr. I am work for Oregon Department of Fish and Wildlife. I'm our statewide fish passage coordinator, and I just wanted to emphasize that BDAs do require a fish passage approval permit from our agency. I linked that in the chat, and I know Sabra said she'd add that to the resource page, but I just wanted to reiterate that that permit or approval runs separate and for parallel to the other permits that would be required for projects associated with BDAs, but it's not necessarily something that's integrated or already a part of a general permit that you may have with another agency. I also wanted to mention that fish passage approval and discussion with ODF&W also should occur for the stage 0 projects, as previously discussed, particularly those that involve, channel reset, cut and fill, a complete fill of the channel, that can represent a temporary, or certainly does represent a temporary barrier to fish movement. So some of those things in thinking about fish movement as it relates to both of these actions, maybe we'll get into this later in the webinar or in the field, but both actions can have, temporary impacts to fish habitat and to fish migration, with the long-term goal and benefit of restored habitat and overall improvement. But just wanted to mention that and sort of mention thinking about citing BDAs as well as stage 0, weighing some of those risks, some of those potential short-term impacts to the environment versus long-term gains. So thank you.
Yeah, thanks for that. And yeah, I did definitely gloss over ODF&W's role in the permitting process, but we also work with local folks from ODF&W in the planning phase of it, and so there's been some adjustments to our project that I didn't mention before that were specifically thinking about fish passage. So one of our adaptations to the stage 0 larger project is having a very small fish passage pathway through the project area during that earth moving phase, where stage 0 sort of grades the whole valley to a 1% grade line and then releases water, and deposition creates those flow pathways. But as was just mentioned, that fish passage can be a little bit slow to develop. And so one of the ways that we're trying to assist with fish passage during that sort of early stages is putting in a very small fish passage pathway channel through the project area. Yeah, and again, ODF&W are really fantastic at talking with us, and there's the official process, but there's also the hey, let me come out and see your site, and we'll talk about how to mitigate that sort of fish impact. So for example, we are building our BDAs on a low tide, incoming tide, and that was a direct recommendation through ODF&W's to try and minimize some impacts to sort of fish during the BDA installation project. So yeah, they're a great resource for knowing maybe the best way to do things and knowing more about your fish potential impacts as well. Any other questions or comments? This is supposed to be, a workshop where we, feel free to kind of give comments and ask questions as well.
And we'll be exploring more the architecture of the BDs themselves in day 2.
The other thing is, if anyone has anything that they would really like to get out of these webinars, or questions that they have that they would like answered and addressed, feel free to sort of type that in the chat or come off mute as well. Ashton, go ahead.
Hi, y'all. So I was just thinking about beavers, of course. And so let's just say a beaver just keeps building a dam. Is there ever a point where you would want to remove some of the beaver dam? Or because can't they get really big? I mean, how, isn't like the biggest one like a half a mile or something?
So beavers provide, we haven't really kind of given an overview of like why you would build a BDA or what the benefits of beavers are in terms of ecosystem engineers and all of that stuff. I'm not sure if other speakers are kind of going to delve into, benefits of beavers, but essentially the dam building, really aids the ecological function of these systems. And so we're lucky here at the South Sioux Reserve that these areas aren't abutting private lands or infrastructure where people maybe have a negative view of beaver activity based on, damage or flooding that is happening to their sort of structures or anything like that, infrastructure. So in the lands that we work in, we definitely see them as beneficial agents of restoration success, and we're really encouraging them to build dams. We would not, reduce the size of a dam or alter a natural beaver dam, with the exception that this year we are doing that large stage 0 restoration project, and we did after 10, 15 years of planning this project and assessing the needs of this area, this floodplain area that's disconnected. A beaver did decide to build a fantastic dam in the project area and flood the floodplain, which was causing problems for the actual restoration work that we're going to do this year. So with a heavy heart, I was needed to remove that beaver dam and encourage the beaver itself to move out of that project area so that we can conduct this restoration work, which was unfortunate. And yeah, so have we seen a lot of beaver activities, Melody, in the Wasson watershed? So we've been monitoring beaver activities through wildlife cameras as well as doing dam surveys. And we do this in our adjacent watershed that was restored 20 years ago, as well as a reference watershed that was minimally impacted, and the Wasson pre-restoration watershed. And what we've found is that beavers are really active in South Sioux in our adjacent watersheds and minimally active in Wasson Creek. So we do have some beaver activity like the one I just talked about, but it's most likely just one or two beavers in this area, and they just really don't have enough food at the moment where they are in the Wasson Valley. Although they have made dams with reed canary grass, which is like crazy. Other questions, comments? So I believe after this we'll be going into a short break, is that right, Sabra? And then coming back at 11 for the next speaker?
Well, since we have our speaker on the call, thank you, Brandy, we can come back at 10:55 and get a little bit of a head start. So let's go ahead and give ourselves a 10-minute break. Come back at 10:55 and we'll go into BDAs and coho salmon habitat.
And there was a comment about beavers using blackberries, and that dam that I was telling you about was with reed canary grass and blackberries. So they definitely use what's available to them.
Awesome. Thank you, everyone.
Yeah, and feel free to keep putting questions in the chats as you think of them as well.
Yes. All right, if folks want to come back on camera, if you feel comfortable. We're going to start up again in a minute. Brandy, do we have you back on the call? Oh, we can't hear you. Nope. No. I guess as a backup, do you have a phone on you, a landline or a cell phone? You could call in just for the audio portion.
Could it be would it help if she disconnected and came back in, maybe? If she changed a setting
Sure.
from headphones to, I'm just brainstorming. I'm not a
Yeah.
tech person.
I missed the
Yeah.
start of that conversation. Are we having trouble with the microphone working?
Yes.
Okay. I don't know if you tried this already, but at the top it has mic and there's a little drop down caret and you can select, okay. I figured you've probably tried all that stuff, but.
Yeah, we're still not getting you. That's one thing with doing this virtually is the geographic accessibility is awesome, but there's always some little snag with the IT. But I think all of us have gotten pretty good at troubleshooting.
Brandy, I see your mute button is still on. Is that?
Yeah, unfortunately, I can't unmute. I can only mute.
Yeah, that's happened to me in Teams before where for some reason my Mute is stuck.
Did anyone have any, while we're waiting, any further thoughts or questions from earlier that came to you during the break?
We did have a new resource put up by Jane for citing BDAs.
Oh, excellent. Yeah, it'd be interesting. So it's looking at whether or not flooding and those impacts to roads and communities, and yeah, that's great. And I believe, Sabra, you're going to put together an information package and, you know, have these recordings and other things available to people to check out after the...
Yeah, so the recordings will be available on the same webpage as the registrations. And then I'll have to make sure that everyone's okay with it being shared digitally, but we'll definitely have a resource packet in paper, and then another packet. I'm not sure if it'll be the full packet or partial packet for in a digital form as well. And Brandy, sounds like you already have you via phone.
I hope that is the case. Can you hear me now?
Yes, and there's no echo, so I'll let you know if that changes.
Okay, sounds good.
All right, so let me just short introduction. So this is Brandy Goss. She is a PhD candidate and a Muir Scholar at the UC Davis Graduate Group in Ecology at the Freshwater Ecology Lab, and has graciously agreed to do a talk about the intersection of coho salmon habitat and BDAs for us. Brandy, if you could take it away.
Sure, let me see if I can share screen, the next hurdle.
I do have it pulled up if you want me to drive, but if you want to drive, that's good.
Okay.
We see ourselves right now.
You see.
You want me to pull it up?
I think I got it.
Okay.
Good now?
It's very small for some reason.
Okay, I think it's on the wrong screen, so I will try one more time. Okay. Sorry that I'm the tech snafu person.
Hmm.
Better?
Yes.
Okay, perfect. I'm glad to be here today. I'm glad to have been invited. Very exciting. So I'm going to talk a little bit about my first chapter of my dissertation, which is about what stable isotopes can teach us about coho trophic pathways and Beaver Dam analogs. And so, let's see, I'm sure I don't need to tell most people in this room that we're experiencing significant biodiversity declines, and that freshwaters are actually experiencing declines in biodiversity that are greater than those in the most affected terrestrial ecosystems. But luckily for us, Beaver Dam analogs and beaver structures can potentially influence both. And the state of the salmonids, just more specific to my project, indicates that in California specifically, we're expecting declines of salmonids, and the report indicates that 74% of extant salmonids in California are at significant risk of extinction within the next 100 years if we don't change what we're doing right now. One of which is the Southern Oregon, Northern California coast evolutionarily significant unit of the coho salmon, and they are both state and federally threatened. But some of the tributaries that I work on are a remaining stronghold for these fish. So the map's a little difficult to see, but if you look up in the kind of red outline in the top of the state here, and that's popped out in the bottom right, I work on French Creek and Sugar Creek, which are delineated by an FC and an SC here. And so while they're a remaining stronghold for this fish, they still face significant stressors such as climate change and water drafting for agriculture and pasture in the Scott River Valley. So the question becomes, what options do we have to support these remnant populations of fish? Beaver restoration is undeniably becoming an important restoration technique that's garnering increasing attention, in part because they produce these keystone structures which significantly alter habitats by modulating flow, temperature, and sediment movement in ecosystems. And some of these impacts are particularly important for the Southern Oregon, Northern California coast coho especially, because they create refuge habitat and rearing habitat for coho salmon. So they're listed as a top priority for Southern Oregon, Northern California coast coho. Again, beating a dead horse, but the beaver were locally extirpated in many places across both the United States and Europe during the fur trade. And this reduced prevalence of beaver and their structures across the landscape, which we're now learning are pretty important and deliver a lot of benefits. And this is also true in the Scott Valley, which was actually historically referred to as Beaver Valley. So reintroductions might be desirable, but they can be challenging in a lot of situations, both ecologically and socially. And so Beaver Dam analogs might be an alternative to reintroduction, or they might be a kind of bridge to reintroduction and kind of improve the likelihood of success of reintroducing beaver in places where the habitat might not be as good as it once was. So I've got a couple pictures here of the BDA structures and for this portion of my dissertation, and then a natural beaver dam on the same tributary, which is Sugar Creek, in a couple different years. So you can kind of see the difference. And this BDA in Sugar Creek was installed in 2014 and was the first in the state of California. So check out the Scott River Watershed Council if you're interested in BDA work. They are doing some cool stuff in the Scott River Watershed Council, or excuse me, the Scott River Watershed. Some things that we know about Beaver Dam analogs so far. We've got evidence of increased habitat heterogeneity as we're creating this pooling habitat. That might be obvious, that we have that in interspersed with the more traditional ripple habitat. We found thermal buffering and groundwater recharge in a few publications, increased resilience for the macroinvertebrate community as well, and some evidence for increased smolt production. I think this paper by Nick Bowes was on steelhead. But little is known about the food webs in these systems and what that means for species of special concern like coho. And so as a little bit of a review before I get into my study, beaver historically influenced the Scott Valley ecosystem, and beaver populations were significantly reduced by fur trading and still haven't recovered in this area. We know that beaver provides significant benefits for stream organisms, including coho salmon. And reintroductions can be challenging and are not always successful. And so in cases where they're not feasible, BDAs might be a viable option for providing these abiotic and biotic benefits for coho salmon. And while one study has looked at the impacts of BDAs on lower trophic levels, like macroinvertebrates, my study, I think, is the first to look at how these changes may impact trophic pathways for species of special concern like coho salmon. And so my broader question here is, how do Beaver Dam analogs influence coho trophic pathways when compared with a reference habitat? So the first thing I should probably do is show you what the reference habitat looks like. So when my samples were taken in 2019, this was the reference habitat. It's about 1 kilometer upstream on Sugar Creek of the Beaver Dam analog habitat, which looked like this in 2019. And so to answer this broader question, I did it in 3 kind of subparts. The first of which was, do aquatic macroinvertebrate communities differ between the BDA and the reference habitat? So I wanted to confirm the results from the core line study that was done on a neighboring tributary, French Creek. And so to answer this question, I collected 3 composite samples that were 3 subsamples, so a total of 9 subsamples that were then combined into 3 composite samples. These were then sorted and subsampled and then sorted in the lab and ID'd to family. And I calculated some traditional community metrics like density, richness, and diversity of macroinvertebrates. And we used a functional feeding group approach here. So just for anyone who doesn't work commonly with macroinvertebrates, I'll explain what those are really quickly. So we broke them down into 4 main groups, which are collectors, which are eating cestin, which is basically floating organic material in the water, or like FPOM on the ground, which would be a gatherer. So that's still organic material that's been broken down by other invertebrates. Predators, which obviously eat other invertebrates. Scrapers, which eat plant matter on surfaces and biofilms, so think snails, for example. And then shredders, which are eating coarse particulate organic matter. That's what the CPOM is. And effectively, the CPOM turns into FPOM, the fine particulate organic matter. Okay. So some results for this first question. We looked at macroinvertebrate taxonomic richness. In this figure, you see the BDA on the left and the reference habitat on the right with taxonomic richness on the y-axis. And it shows that there was reduced species richness in the BDA habitat. When we looked at average density of macroinvertebrates with the BDA again on the left and the reference habitat on the right, we found increased density in the BDA habitat and also some more variation across samples taken in different microhabitats in the BDA. And when we looked at them at the functional feeding group level, so we split this average density out between those functional feeding groups that I mentioned earlier, we found higher density of all functional feeding groups in the BDA. But this was notably higher for predators and shredders, which we found kind of interesting because typically predators don't make up a huge proportion of the macroinvertebrate community. Okay, so we've established that there are some differences between these macroinvertebrate communities. And so my next question was, how does that transfer to the trophic pathways for BDAs and reference habitats and the coho feeding in those 2 habitats? To answer this question, I used the stable isotope approach, and I'll get into a little bit more about what I mean by that. But basically, we started by kind of collecting all of these different food web constituents in each of the 2 habitats. So we got aquatic plants, the cestin I mentioned earlier, so we filtered that out of the water, the floating organic matter, particulate organic matter, so these kind of dead leaves and things that accumulate in the water that invertebrates eat. Obviously, macroinvertebrates we sampled, and then we used coho fin clips as a non-lethal method of sampling the coho salmon that are rearing in these habitats. We sorted the macroinvertebrates and ID'd them to family, and then I had the lucky task of processing all of these things after they were dried into these very tiny tins. And mercifully, the stable isotope facility at UC Davis did the chemistry for me. They sent back these carbon and nitrogen values. And I'll explain how I use those to reconstruct the food web in a couple slides. And I use this model called MixIR to do this food web reconstruction. So you might ask why I use stable isotope analysis. Well, the main reason is that this method can provide good accuracy for more food web constituents in a relatively non-intensive and inexpensive way. And it also gives us a longer term picture of what these organisms are feeding on with more of an average over time, rather than the kind of snapshot we might get from stomach content analysis. The next question you might ask is, why would you use carbon and nitrogen for food web reconstructions? And so I'll try to move through this explanation as clearly as possible, but the short version is that these isotopes, the difference between them is that one has more neutrons than the other. So there's a slight weight difference in them. And if I asked you to push a rock up a hill or roll it down the hill, you might preference the lighter one pushing it up the hill and the heavier one pushing it down the hill, so you don't have to keep pushing it. And so the same is true in different biochemical processes. If we have these different processes happening, depending on whether it's pushing the molecule up the hill or down the hill, it might preference the light or the heavy isotope. And so for nitrogen, for example, this one typically preferences the heavy isotope as you move up the food chain. So you see that the ratio of heavy isotope to light isotope is increasing as you move up this food chain in panel C at the bottom here. And so we can kind of use that as a marker for trophic position because that ratio changes in an increasing way that's relatively reliable as you move up the food chain. And the rate at which that changes, we call a trophic enrichment factor. Carbon is a little bit different. It doesn't typically change a whole bunch as you move up the food chain, but it is treated differently by different photosynthetic pathways. And so it can kind of create a spread between different primary production sources at the base of the food chain. And so if you look at a food web, you end up with something that kind of looks like this figure on the right, where you have more heavy nitrogen isotopes at the higher levels on the y-axis, more light nitrogen isotopes, and lower on the food chain at the bottom, and then this kind of horizontal spread with carbon isotopes at the very bottom, depending on what primary production sources they're depending on. And so mix-IR, the math magic that happens once I get these carbon and nitrogen values, basically it takes the consumer carbon and nitrogen means and variations, the source carbon and nitrogen means and variations. So for coho, I would put in each of those four functional feeding groups, the carbon and nitrogen means and variations for those. And then the trophic enrichment factors, which are sourced from a broad body of literature that is developing to indicate what the expected rate of increase is for each of these carbon and nitrogen values as you move from source to consumer. The model then puts these into a general mixing equation or a variation of one, and it gives you a % dietary contribution for each source. And so those % dietary contributions for each source will give you an idea of what each consumer is feeding on at what rates, and allow you to kind of reconstruct not only the connections in these food webs, but also the kind of strength of those connections. And so the results for this, I'll focus on the coho here. We had in the Beaver Dam analog habitat, predatory invertebrates were composing 63% of coho diet and 32% in the reference habitat, which is kind of crazy. One, that they're so highly dependent on these predatory invertebrates, and two, that it's double what it was in the traditional stream habitat, this reference habitat. And the diet was much more varied as well in the reference habitat, whereas in the BDA, the predators are clearly dominating the diet. And so the third question, I wanted to kind of contextualize these isotope results, because by themselves, it's an interesting finding, but it doesn't tell me a whole bunch about what the mechanism is behind what's driving that increase in reliance on predatory invertebrates. So we wanted to know how they correlate with differences in food abundance and community composition between the BDA and the reference habitat. And so one way we did this was we compared a ratio of the % diet contribution to the relative abundance of the macroinvertebrate group. So does the % diet contribution, is that equivalent to the percentage of predatory invertebrates in the macroinvertebrate community, essentially? And so a value of greater than 1 here would indicate that that macroinvertebrate type is contributing disproportionately to coho diet. What we found was that in the Beaver Dam analog habitat, they were feeding on predatory invertebrates at 2 times their relative abundance in the habitat. And in the reference habitat, it was over 5 times their relative abundance in the macroinvertebrate community. So this seems like they're clearly preferencing these invertebrates. And some future research, there's some folks in my lab who are working on fish feeding behavior on this. And I think would really like to work on some kind of spatial distribution analysis of what's happening in these 2 habitats. But it seems like they're preferencing these predatory invertebrates. And these trends correlate with a wealth of research that has shown that prey size and abundance are 2 key factors influencing prey selection by salmonids. So predatory invertebrates are frequently larger. They were obviously more abundant in the Beaver Dam analog habitat. And so we see that with my first 2 points here. But I think these results are also indicating that the reduced species richness and potentially also the increased variation in sample density, so the kind of quality of the different patches might also be playing a factor here. And these characteristics together might be improving fish feeding efficiency by basically making this preferred food resource more abundant, more easy to search for, and more easy to access in Beaver Dam analog habitats. So my conclusions here that obviously diverse and resilient habitats will be crucial for coho conservation, and beaver restoration might be part of that. And BDAs appear to deliver both abiotic and biotic benefits for coho, as evidenced not only in my study, but also in a wealth of an increasing wealth of research on beaver dam analogs. And our thinking here is that part of the story here might be more optimal foraging for juvenile fish in BDAs, and that consideration of not just the density of prey resources, but also the composition of them might be important, especially for a visual predator like salmonids. And so with that, I will say thank you. I've got the Scott River Watershed Council's website here. If you're interested in finding out more about the work that they do, it's pretty exciting, and they continue to do more work every day. So with that, I'll say thank you and see if you guys have any questions.
Thanks for a great presentation, really interesting. While other people are thinking of questions, I'll just jump in and ask one to get us started. Could you tell us a little bit more about the setting of the BDA and the reference habitat? I'm kind of curious because they looked really different, you know, in terms of stream shading and other plants in the area. And yeah, I was just curious how you chose your reference habitat, what sort of characteristics you were looking for. Is this a habitat that you're striving to get towards, or is it one that you're not, you know, that you're moving away from by putting the BDAs in? Could you just tell us a little bit more about the setting, I guess, of the work?
Yeah. So there's a two-part answer to that, and the first is that the Scott Valley is, the land ownership is often very divided in terms of whether they're on board with restoration projects and whether they're on board with science. And so part of the decision making in terms of selecting sites was based on landowner access. It's mostly private land ownership in this area. We tried to get a location that was relatively close by so that the macroinvertebrate communities, at the start at least, would be similar, I think, to kind of see what the change over time was with a reference habitat that would have a similar prey base to when they were installed, I guess. And I think we were trying to characterize the reach of this stream as well in the reference habitat and see kind of like looking at a location that hadn't had restoration done previously on it, looking at a location that wasn't beaver influenced, and looking more broadly at a location that was characteristic of the tributaries that are in this area. And the third component of this is that I didn't actually collect these samples or select this site. This data was available when I started my PhD. So these are my best guesses on what my advisor did.
So the reference site, is that aimed to be a something that we're moving away from with our restoration actions, or moving towards in our restoration actions?
I would say neither. I think it's more so this habitat heterogeneity that's increased with the Beaver Dam analog habitats and the potential life history diversity that results from this habitat heterogeneity, I think is more the goal that I have arrived at. I don't think either of them are bad. I think they just have different purposes, maybe.
Okay, thanks. It looks like we've got at least one hand up there, but I can't see who it is, so you can just pass it over.
That would be me. I'm wondering if you also looked at, you know, kind of what was just mentioned, like the two habitats looking really different, and if you looked at levels of dissolved oxygen, how that might be affecting the invertebrate communities. You know, with a lot of riffles, you'd expect a little more oxygen versus the beaver dams are going to kind of take that away. If that was, if that would be of any use to look at that, or if you thought about that.
Yeah, I think there's a lot of different things that are driving the differences in these invertebrate communities, and that's certainly probably one of them. We didn't look at that specifically for this project, but we have another stable isotope project that I'm working on that uses sulfur stable isotopes that directly plays on that. The difference in the anaerobic and aerobic respiration that happens between them results in these different sulfur signatures, so we can trace habitat use.
Mm-hmm.
So I'm going to be constructing the life histories of adult spawners to see kind of what habitats they were rearing in.
And I have sort of another question about salmonid ecology that I've only kind of know a little bit about, but this idea that actually the life history of salmonids might be to be very adaptable to different environments. That is actually a life history strategy to be able to use a lot of different kinds of habitats. You think like estuaries are kind of unpredictable, and so that there's kind of an idea out there that that's actually part of salmonid ecology, is to not necessarily have just one preferred habitat. Do you have any thoughts on that?
I don't know at the individual level. I do know that there's a lot of interest in my lab and this portfolio effect that I think I mentioned earlier, and the idea that life history diversity, the ability for at least some individuals to kind of have like rear in a different habitat type and have adaptations to rear in that habitat type. As we experience these increasing changes in climate and in land use and all sorts of different things that are occurring, it's advantageous to have organisms that have these different habitat utilization strategies or timing strategies.
Right.
And so that's definitely a big interest in the salmonid community for sure.
Yeah, thank you. Thank you so much for your presentation.
I think we have time for one more question if someone has one.
And while we're waiting for that question to come in, just letting you know, we are doing macroinvertebrate monitoring as well as part of this larger restoration project. And we'll be looking at the two areas where the BDA complexes are, as well as several reference sites in our area.
Cool. Yeah.
Didn't think about stable isotopes, so that was really interesting.
Yeah, I'm very grateful that I just have to interpret the numbers. I don't have to do the chemistry, but the things chemistry can tell us are certainly really cool in ecology.
Well, thank you again so much for joining us and sharing your thesis in progress. Would definitely say that when you do have that available, we'd love to hear about it and disseminate it. And please stay on if you have time. We have a couple more speakers that I hope that you'd find interesting. But we will switch over to Damien for process-based restoration fundamentals. Damien, you're going to drive your own PowerPoint, right?
Yes, I will.
Okay.
Let me see how I do here as far as setup.
Yeah, if you just click the presentation button, we should be able to see it. That looks good.
Okay. Yeah, I really want to thank Brandy Goss for joining us. We had our Salmon Restoration Federation conference in California, which is basically our main kind of stream restoration conference we have down here. And her presentation, it's just really important research she's doing, looking at these food web connections to restoration actions, which is, it's really important from an adaptive management standpoint. And we had a number of other presentations that where we're getting more quantitative data on these beaver and process-based restoration approaches, not only with Brandy's work, but also with looking at fine sediment capture and water quality. So hopefully we'll have some more of that information to show you all and share over time. So my name is Damian Ciotti. I work with U.S. Fish and Wildlife Service Coastal Program. I've been doing beaver and process-based restoration throughout large portion of California and Nevada and up into Southern Oregon for quite a few years. I started out in more of a channel restoration kind of engineering approaches years ago in the Klamath, and in fact I learned quite a bit from the Klamath and Scott River watershed folks. They were some of the earliest adopters of these approaches that Brandy mentioned back in around 2010. Yeah, my background is I'm a soil scientist, and you'll be also hearing from Jared McKee tomorrow, who's a civil engineer and hydrologist. In this first presentation I want to show you is kind of more of the larger landscape view of thinking about process-based restoration and where to apply beaver restoration and how to integrate it with your restoration projects. So when we think about why do beaver build? What are they trying to do? What are their goals and objectives? I mean, we don't know exactly, but looking at different projects and working with beaver, I think about three main things beaver are trying to do. They're trying to maximize vegetation production on a site. They're trying to create deep water habitat for their own protection. And they're trying to expand a channel network so that they can move out and increase, get more water out onto the landscape and increase that production and move materials from dams or move material they're eating or for lodge building. And so, inadvertently, they create this extremely large, complex network on lower depositional valleys like this. And when we think a lot of about a lot of streams that so it's not only beaver that can do this, but it's also wood loading and other depositional processes that end up with these more complex depositional zones. And so here I have two examples of where we have stream systems that are generally healthy looking, but they do lack that structural component within the channel itself. And on the left is more of a wood loading need where you would use process-based restoration to kind of mimic wood loading within that system and add small wood or wood structure. And then on the right, more of a lower energy system where you would apply beaver mimicry within that system. But when we're thinking about process-based approaches and using Beaver Dam analogs, we also think about what other source problems are at that site, obviously, and think about using these structures within that context. You often are going to have other major restoration problems to deal with, whether that's infrastructure or land use. And oftentimes you might have to deal with these before you can think about using these approaches. And these, Beaver Dam analogs are going to be more effective if you can address these other major source problems within your system. And then, all of this work we're doing within a watershed context. Alice, she presented some really great approach, catchment scale approach that they're taking with the project that you'll be working on. But thinking about, different zones of your watershed, how, what impacts have occurred on those areas through infrastructure and through land use and the changes that are going to affect your project at the more local reach or site scale where you're working. And then, more recently, this stream evolution triangle that Janine Castro with U.S. Fish and Wildlife came out with a few years ago. It's a good concept model to put your project within and think about your site. Is it more influenced by the hydrology, geology, or biology? And with Beaver Dam analog projects, we're going to be up here in this lower gradient biological influence area. It's is where we're going to be most effective with our projects. So a few years back, we came up with kind of another conceptual model of identifying important components to look at with your project for a process-based restoration project. And initially, in a lot of cases, we're looking at these locations where there's heavy infrastructure, agricultural lands, perhaps, with land uses that are constraining or confining the stream's ability to, recover and self-heal over time. And so we thought about the, how do we approach these? And first, we're thinking about space and the space that potentially could be available to the stream to recover. And then energy that's available on the site. So the type of stream energy, is it a spring or is it more of a runoff type watershed that you're working in? And then what's the potential to regrow vegetation within that system and bring up the water table? And so thinking about your kind of often narrow incised stream channel within the context of a larger valley and restoring that connectivity is really fundamental to what we're what we're doing with these projects. And then thinking about the existing materials on site, sediment supply, and vegetation that you'll grow over time. And that's a little different than how we traditionally approach these projects in a form-based approach. And not to say that this approach is wrong, and it has its place and need for it, particularly where you're in confined areas near infrastructure. But in many respects, we bring in too much material from off-site. When we do that, we end up overstabilizing systems and kind of reducing the potential for a more dynamic restoration project at the site. And so a few years back, we did publish an article in Bioscience, kind of focusing down on these key metrics for a restoration project and thinking about the amount of space that you can reconnect within a project, the natural energy that you can potentially use to meet that objective, and natural materials, and that you're working adaptively over time. And these were key design criteria we established for process-based restoration projects, and working with Forest Service, National Marine Fisheries Service, and UC Berkeley. And so a lot of this presentation is from that paper, if you're interested. So really a key thing to think about early on at your site is channel evolution, because it's really the recovery, the natural recovery of the system is going to take place within this channel evolution model typically. And so you start with kind of these degraded incised channels in many instances. And from this, a lot of times you're going to go through this slow evolution of aggradation and increases in vegetation to more connectivity within that system, which is the direction beaver will take a channel if they start working in it, and they have the ability to, if there's some vegetation supply, they will accelerate this evolutionary trajectory here. But then there's also this short trajectory where perhaps within this incised channel, there's potential to reconnect directly to the floodplain. And you can get these degraded sites back to a stage 0 or reconnected floodplain rapidly. And so when we're looking at a site, we're thinking about these two evolutionary trajectories, this kind of short circuit one, and then this long-term evolution. And beaver are doing both as well. And oftentimes many sites will involve both of these trajectories. So here you have, as you go from this stage to this stage 4 or 5, where you start to get vegetation, you start to get more depositional sediment bars within the channel. And then you start to get vegetation on those depositional bars. And then you start to come back up to reconnect the floodplain. And then here you have a reconnected kind of stage 0 floodplain. So, thinking about that model, here is a overview of Doty Ravine. This was a site in the Sierra foothills that we restored in California at around 500 feet elevation, Mediterranean type climate. And as you can see, this site started out as a very incised creek system, disconnected from its floodplain, very similar to what Alice showed earlier with the site you'll be working on. So early on, we didn't think, exactly where do we put structure. The main focus was what are the source problems. There was overgrazing at this site, beaver depredation. They were trying to use the floodplain for an oak woodland mitigation project, which if you looked at the soils, these soils are alluvial, fluvial soils, and that oaks historically would have been up on these terraces. Of course, there was incision, and in places there were levees as well. And so simply by addressing these source problems and encouraging the beaver activity, this site did reconnect within 3 years. And simply by, I should say the main focus, really addressing the land use was the main challenge with this project. And all we simply did was reinforce beaver dams within the channel itself. So going back to the design criteria for this site, we're really thinking about space. What's going on within that floodplain space? And how do we get this narrow channel corridor reconnected to that floodplain? And working with the landowner so that we can adjust infrastructure and the main land use, which at this site was a cattle operation. And so that not only requires looking at the land use and infrastructure, but also the geomorphic context. And does this have the potential to reconnect, given the sediment supply, given this slope? And this is just looking at a different perspective. This is where we reinforced the beaver dam here and reconnected the floodplain. And you can see this anabranching channel flowing through the floodplain at base flow during the summer. And so just to give a brief design overview, this is the site on a LiDAR bare image here. And the yellow represents the natural dynamic space available for connectivity within this system. And that's about 67 acres on this particular property. And then when we look at what was connected at the time we started the project was just this narrow corridor. That's around 7 acres, we estimated, of this narrow fenced out corridor. And so through, as I mentioned earlier, as changes in land use and then working with Beaver over time, we reconnected about 57 acres. So this gives us that quantitative space criteria to really focus on for when we're coming up with restoration plans and activities for a site. Just an overview of the Beaver Dam analog locations that we, Jared will go into more detail on structure placement tomorrow. So after space, then we're also thinking about energy. Obviously, fossil fuel heavy equipment is going to be necessary, particularly where we have infrastructure or we have to work around infrastructure and we requires removal of earth or bringing in other materials for stability. Solar productivity, really key for growing vegetation at the site as you're bringing that water table up. And then thinking about where beaver dams need to be reinforced in locations. And then, I mean, perhaps not just beaver, but thinking about ecological engineering species, whether that be willow, beaver, oysters, depending on the location, mussels. These all had huge influences on these systems prior to when they were degraded in many locations. And then obviously flood pulse, what's coming through. This is going to rework the system, create new channels, fill old incised channels, and really restore that dynamic you want at the site. Just a look at here was a Beaver Dam or a Beaver Dam analog placed over in this incised channel. By year 2, we started getting floodplain channel formation and deposition. By year 3, we get growth, vegetation around that new channel. And then material. Key point with material is, do you have sediment supply within the system? If you're working in a spring system, that presents different potential challenges. And then can you get vegetation growing, or is there sufficient vegetation on the site to really do a project like this? At this particular site, we don't have dams upstream. There is a pretty healthy sediment supply. As you can see, there's sediment sorting and bars within this system. There's vegetated, already started vegetated inset floodplain within this incised channel system. So we build our Beaver Dam analog here with the materials and in order to capture sediment. And then we also get this productivity going so that we're, it's not just about the structure, it's about getting all that other vegetation growing so that it enables your project to capture more sediment and increase its influence on that space and landscape. Another example here where Beaver brought up this water table elevation of this incised channel going up the edge of the valley here. And you can see what this does. This just increases productivity of the floodplain. And so, it's not just the Beaver Dam that's capturing sediment. It's this whole restored floodplain that's really capturing sediment and providing those benefits that you're after. Finally, the last criteria I wanted to talk about is time. Year 1, this is a floodplain, again, at Doty Ravine. We removed a levee here, and then we placed a beaver dam. And we see year 1, that beaver dam blew out. Beaver Dam analog blew out. We have a channel meander. And then year 2, we followed that blowout and expanded that beaver dam. We start to get floodplain reconnection. Then by year 3, we have a new channel avulsion going out onto the floodplain during base flow conditions. So just a few other kind of key points about beaver. Here's an example of a large beaver dam. We have a typically with large dams I see in systems, we do see fish bypass channels naturally going around them. Beaver build dams and they allow for a bypass channel to go around typically. Now, there are cases where in tight infrastructure areas or perhaps during low base flow periods where this, these may not be as, may provide or may not provide passage, but those are in those rare cases that I've seen. A lot of times head cuts people are worried about with these projects. Once you start to restore the floodplain connectivity and vegetation and water table, you see a lot of roughness added with this new vegetation. So here's a head cut forming as we have a stage 0 floodplain that is reconnecting back into an incised channel. But when you look at, here's an old head cut from a previous year, this regrew vegetation and stabilized. So, just point here being that a lot of times the gut reaction is, oh, we need rock, we need to stabilize this. Well, if you're really restoring a lot of processes on these sites, they can recover, do a lot of this recovery on their own. This is an example. We're not always using these structures as beaver dams. A lot of times we're using them more as wood loading mimicry. So here we're mimicking wood to encourage widening of this channel and recruit these trees. And so over time that, uses that stream force energy to create this kind of center island of trees that slump in and increase that channel evolution recovery. And finally, just an example here of where you have an incised channel still on the site. We didn't fill this whole channel, but we have a reconnected floodplain in stage 0. So you can have multiple stages of channel evolution occurring at once. And we learned that from Beaver. Beaver reconnected this floodplain, but we still have incised portions of it. And, it just adds a lot of complexity to these systems as they recover if you don't necessarily need to have everything be stage 0 at once or, one particular type of stage. Beaver don't seem to mind having multiple stages. And, this all happens over time. And so it's important to monitor what's going on here. With this particular site, we're looking at flows relative to different restoration actions. And then looking at the change in stage 0 or reconnected floodplain over time. We see that occurring here. 2017, we start to see the floodplain reconnect and increasing connectivity through 2019. We also looked at costs and other factors here. And then some of the challenges. From the beginning, I underestimated how much space we would reconnect. So you can see a lot of our riparian fencing is within the wetted area. Aquatic invasives, they're still an issue. As we restored the hydrology of the floodplain, there were invasives within this stream system, and that's a challenge we still face at this particular site. And then cattle management is, something that you just have to work through over time. And we've learned some lessons there working with this cattle manager in a stage 0 system as well. And then finally, I think integrating low-tech process-based restoration and construction restoration is something I'm still learning more about. There are certainly sites where I'm going back in and using construction where previously we weren't able to meet our objectives perhaps with low-tech PBR, or to contrast that, there are locations where I see construction being used and I'm like, wow, we could have used low tech at those sites. So it's, there's a lot, still a lot to be learned, and I think integrated. And the work Alice is doing at this site, I think, is really great, where they're working with integrating both approaches that you'll see at the field study site. So anyway, I just want to conclude. If you want more information on this presentation, please check out our article in Bioscience, and key points, really define that fluvial space that you're potentially going to reconnect. What was naturally reconnected within that system you're looking at? Think about your energy, stream energy, or in a spring system, or more of a flow, higher energy system. And then your material supply, sediment supply, potential to regrow vegetation, and thinking about this project over time, multiple years out, thinking not only from planning from a funding standpoint, permitting standpoint, and in monitoring that change over time to make sure you're meeting your objectives. That's all I have.
Great, thank you so much. I think we have time for 1 or 2 questions. Feel free to put it either in the chat or raise your hand. Or just hitting them with a ton of information today. All right, for those of you that are coming to the field days, remember that Damien will be one of the 2 main instructors on site. So, I'll make sure to get everyone's contact information and put that in the resource packet if anyone has follow-up questions. And it does look like we have a hand raise with Charles. I can only see part of your name. I hope that was it.
That's fine. Yep, Charles. Hi, thanks a bunch, Damien. That was a great presentation. I'm curious if there's a preference. You've identified, deciding is it a high energy or low energy site. Is there a preference for conducting these restoration activities along those continuums that you outlined? Obviously, at least to me, it seems that space, certainly we would want to maximize space, but dealing with energy and material constraints, what is their preference?
Yeah, I mean, I guess I'll first say no site is perfect. There's always one of those, material, energy, or space is at least one of those is typically an issue. But within these systems, ideally, your fastest recovery I see is within systems that have enough energy that they are pushing sediment, but also have, but they're low enough that allow for vegetative growth pretty quickly within that system, so that the system's able to do geomorphic work and push sediment, create new channels, but also not so much energy that you can't get vegetation quickly established and growing. So, in Doty Ravine, this test case, which was a tributary to the American River, was, that kind of case. We had a good sediment supply, enough energy that you could get work done, but not so much that you were totally kind of blowing out everything every year. Yeah, I guess that's the short answer.
And then we have one question in the chat before we move along. I've been thinking, this is from Brandy. I've been thinking a lot about planning for the future versus planning for historical baselines and the possibility of creating ecological traps by modifying landscapes. Can you speak on how you deal with this future conditions versus historical conditions and maximizing benefits while minimizing issues with these newer approaches and techniques?
Yeah, wow, that's a really good question. And looking at historical conditions, I mean, usually the best we can come up with is a conceptual model of what we think the historical conditions were. And that's going to be based on a lot of characterization of everything from soils, geomorphology, historical documents, maps. So it's really an investigation that you pull this kind of multidisciplinary amount of information together and piece together what you think was probably there. And then but what we're creating with a process-based approach is that we're allowing the system to do a greater portion of the design, and in fact, that's what we're giving nature a seat at the design table. We're not making assumptions about fully making assumptions about what should be there, and so our goal is a little broader than perhaps historically what I used to do, and that was, really come up with a blueprint of the habitat we're going to construct, versus what we're doing with a process-based approach. We're relying on that natural energy and recovery to occur to create new habitat. And whether that, I think you're bringing up a good point. I think within the context of where it is, thinking about ecological traps, I think that's probably more of a site or valley scale thing to look at, for sure, within any of our restoration actions.
Thank you very much. So we'll have one more chance for questions before we wrap up today, but for now, we're going to move on to our next speaker, Dr. Emily Fairfax. I think I saw you on the call earlier. So let me find your info. She's the assistant professor at University of Minnesota in the Department of Geography, Environment, and Society. And I'll hand it over. Do you want to drive your own PowerPoint or do you want me to pull one up?
I will drive it.
Cool. And that looks great.
All right. Awesome. All right. So thanks for having me, everybody. I am here to talk to you today about Smokey the Beaver and how beaver wetlands are able to create fire-resistant natural infrastructure. And I want to talk about this with the context of, obviously, most of my research is on beavers, but that we are increasingly thinking more and more about how do we get those beavers back where we need fire resistance, how much fire resistance can they provide, and what is the role of process-based restoration in creating similar or the same amount of fire resistance. So with that big intro, let's start off. Climate's changing, right? And what is normal today isn't what was normal in the past. We are seeing things get increasingly hot across the planet, and there's really no sign of this stopping. If you look at these maps of our average annual temperatures over the last 100 years, every single decade is hotter. And we're feeling this very acutely in the air temperatures. We're feeling lots of heat waves and heat domes and the things like that. But we're also feeling it in terms of natural disasters. We are seeing a significant uptick in the intensity and the frequency of our droughts, our floods, and our wildfires. And all of these disasters are connected to one another. We are smart as a species, and we can get our way out of this. We know that we need to be building more climate resilient landscapes. And in many ways, that is an engineering problem. We literally need to build the climate resilience into our landscapes. But that building is expensive, and engineers are highly trained, at least in human society. And so it's not always clear if we have exactly the right amount of hands on deck and money at hand to build as much climate resilient landscape as we actually need to deal with these disasters. But luckily, we're not the only engineers out there. There's also nature's engineers. And so, yes, I'm talking about beavers. And yes, all those things that I just talked about, excessive drought and flood and fire, are within the beaver's sphere of natural engineering. So beavers and wildfire is really what I want to focus on today. And you may not have really talked about beavers and wildfire in the sentence together before, and that's okay. This is a relatively recent area of research in the scientific community, but it's something that we've been seeing happen for literally hundreds of years. There are observations of this written down in all sorts of old journals and writings, but the data has really come a long way, and that's what I'm going to talk to you all about, is how exactly do beavers and wildfire relate to one another, and how is it that beavers can help us create fire-resistant natural infrastructure? I want to start off by showing you a picture of a pretty typical beaver dam landscape. So over on the left-hand side of the screen, you will see the Beaver's Dam spanning across that channel. It's got a little pond behind it. We have water flowing across the front of that image as well as the stream continues on downstream. There's a variety of vegetation here. There's reeds, there's trees. You'll notice some of the trees don't look so hot. This is from a wildfire area, and the fire was nearby to this beaver pond. But in general, there's a lot going on here. It's complex. It's complex in the vegetation, it's complex in the hydrology, it's complex in the geomorphology. And this complexity looks nothing like what most of our streams look like in reality. Instead, we see something a little bit more like this drawing in the bottom left. Most of our waterways, especially in the American West, are incredibly simplified. Instead of having many pathways for water and a diversity of vegetation present, you have a single simplified path for the water. The stream has often cut down or incised, and so it's no longer connected to its floodplain. It's very difficult for water to move between the physical earth and the stream channel itself, and there's not a lot of ability for that stream to provide support to a riparian or creekside ecosystem. And this is a challenge. These degraded riverscapes are very vulnerable to climate change. They get worse and worse and degrade themselves further every time there's a drought, flood, or fire. And that's difficult for us, but it's actually not that difficult for beavers to deal with. Beavers see a stream like this as an opportunity. They're quite easy to dam for them in many cases, and that's exactly what they're going to do. So step one, beaver comes in, starts building a dam. That dam is going to slow the water down. And I want to be very clear, beavers do not stop the water. They are not building concrete dams. They do not use rebar. They are out there building leaky structures that water can flow through. It can also flow over, it can flow under, it can flow around. There are many, many ways for the water to get from upstream to downstream, although when the beavers are building, that process happens more slowly. And the beaver pond itself does start to reconnect back up to that floodplain surface and build back up your riparian ecosystem. And so this is happening. You're starting to get a little bit of a restoration effect, but this is a relatively small effect to start with. And luckily, beavers are not going to stop with one dinky little dam. They're going to work tirelessly to expand that dam. They want it to be taller, they want it to be stronger, they want it to hold back more water, they want a larger pond. For those of you who have not spent a lot of time with actual live beavers, this is a rodent, this is a semi-aquatic rodent that is anywhere from 40 up to 100 pounds. It's got a body shaped like a bowling ball. There's webbed feet on the back, there's hands on the front, and there's this big tail, paddle tail coming out the rump side. And that's not an animal that's built for overland travel. So yes, they are technically semi-aquatic, but they are much better in the aquatic than on the terrestrial. A beaver walking across the land is very vulnerable to predators, and they know that, and evolution's taught them that. So all this building activity is not because the beavers just enjoy being in the water. It's not because they want to help us with climate change or anything like that. Beavers are doing this because they're safe in the water. For every ounce awkward and unmanageable that they are on land, they are in control and swift and agile and safe in the water. They are outstanding swimmers. A beaver can hold its breath up to 15 minutes, and they can outswim essentially any predator that they encounter. So beavers doing all this is making its aquatic area bigger so that it can be safer. That's building back up an even larger riparian ecosystem. We start to shift a little bit into a riparian wetlands. We can develop a true wetland habitat instead of just the sort of more drier stream side. And over time, the beavers do need to start venturing further away from their home pond to get more food and to get more building materials. And so that's when they dig canals. And canals are probably the most underappreciated aspect of beaver engineering. When a beaver digs those canals, every single one is like a little micro stream radiating out across the valley bottom, across the floodplain, and spreading the water out, giving it preferential flow paths to get out of the main stem into the floodplain, into paleo channels, onto a diversity of flow paths, which further slows it down and further increases the ability to store water and truly transforms what was a highly degraded system into a thriving riparian wetland. And this is all fantastic for the beaver, but this has pretty significant impacts for everything else in the landscape too. So I'm going to walk you through a little bit of the state of the science on how all of that complexity that beavers build into the landscape physically relates to droughts, wildfires, and floods. And it starts with floods. So this is our stream without beavers again, on our left, simplified, not a lot going on vegetation-wise, pretty basic. This is our stream with beavers on the right. We've got a beaver dam cutting across the stream itself. We have water flowing over the dam. We have water flowing around the dam. There's water flowing under and through the dam. I drew the canals on here, and one thing I want to point out that I was very explicit about is that beaver canals don't just extend laterally. They don't just go from the pond out towards the hill slopes. Beaver canals often connect upstream to downstream as well. So they make their own bypass channels. They force sort of fake little anabranches or braids into the river by building these canals, connecting their upstream to downstream. Beavers are very awkward. We've established that. They also don't want to walk up and down over their dam. They'd rather take a little aquatic path, and so that's what they do. So these two systems are going to function really differently during a high water event. Now, whether that is a true flood, like from a big rainstorm, or just a big snowmelt year or something like that, when you have a lot of water confined to a very small stream, that is going to create a very powerful flood wave. And that flood wave is going to make its way down a path that is not able to accommodate it, and as it goes, it will rip your stream apart. We see enormous amounts of erosion when we have high flood waves going through these small, tight, simple streams. There's just not enough space for that water. If you imagine having a garden hose that you turn on and then you cover up most of that hose with your thumb and the water gets very fast and sprayy and more powerful, that's kind of what's happening in these degraded systems. The water is shoved into too small of a space, and so it gets very fast and very powerful. But when it moves into the beaver wetlands, these are very, very different in how they interact with that flood wave. There's deeper water, there's wider water, and there's also all of these little microstreams that help the water find its way out onto the floodplain. And so the flood wave gets delayed. It goes on these meandering paths. It interacts with a lot more vegetation. That's physical roughness for that water. And yes, it does still find its way downstream. Remember, these are leaky structures. Beavers are not stopping the water, they're just slowing it down. But when it goes downstream, it's a lot different. It's not as destructive. And we don't see as much of that erosion and soil loss and scouring that we see in our degraded streams. Instead, what we see is highly efficient water storage, where it's being spread out and slowed down and given time to be stored both in the surface water itself, in those ponds, in those canals, but then also in the soil surrounding them. It's like the earth is a big sponge, and the beavers give water time to fill up that sponge. This is more than just a conceptual model. These are the exact systems that we see over and over and over again. Here we have two large beaver dams in sequence. On the very left, if you squint, you can probably see our beaver lodge, that round structure in the middle with a little pale blue dot on it. That pale blue dot is a person. So there's some very large beaver ponds. But we've got those dams, we've got lots and lots of canals connecting upstream to downstream, an enormous diversity of hydrologic flow paths, and an enormous amount of flood wave attenuation potential here. The beavers are creating environments that are perfect for slowing down and storing that water. And that matters a lot when we think about the subsurface. So same thing here, stream without beavers on the left, stream with beavers on the right. Now we're looking down with depth into the earth, and we've got vegetation along the top there with its roots sticking down into the soil. I've set our water table pretty deep in both of these images. That's very common in the American West. It's also common in actually a lot of parts of the United States. And then we have our stream impacting the groundwater in a pretty narrow scope on the left. And then because the beaver pond is much wider and because every canal is like a micro stream, we have a much larger area of connection on the right where we have those beavers. But honestly, as long as there's infiltrating precipitation, as long as there's rain or snow getting in from above, the plants don't really care if they're by the beavers or not, because there's plenty of vegetation, or sorry, there's plenty of soil water for that vegetation to access. Everything's healthy, everything's happy, nothing's stressed out. As long as we're in a rainy period, which I probably don't have to tell you is not as common as it should be, more often than not, we're finding ourselves in periods of drought. And so when we enter a drought, we lose that precipitation from the top. We are now entirely reliant on water that has been stored in the soil. And in our stream without beavers, there is not a lot of soil water that has been stored. That stream has a very narrow impact. This is dictated by the soil properties and the width of the stream here. And so all those plants that were happy when it was raining, now they can't reach water anymore. They can't reach our deep water table. And so they start to wilt and wither and shut down. That is not the case in our beaver ponded area, however, because that pond is such a large feature and because those canals are like little micro streams that pin the groundwater up to the surface, we have a lot of soil water. And so those plants can continue to drink water from the soil. They can continue to stay green and do their photosynthesis, even if we haven't had precipitation. And I've personally studied this and found that beavers are able to withstand the effects of drought for upwards of 3 years without having any significant relief from that drought. So this can be a very prolonged effect, which matters a lot when we have ignition events. So when a wildfire starts, that fire will take the path of least resistance. It's going to burn whatever is easiest to burn, and that is dry vegetation. So all that biomass that we built up in our river corridor during wet period, but that dried out during our drought, that's now fuel. And that's one of the reasons why we see such intense fire ripping through our riverscapes, is because they're on this boom bust cycle of healthy vegetation. It's all green and healthy when it's rainy, but as soon as we enter drought, all of that habitat turns into fire fuel. We see a lot of burning. And that's not the case again in our stream with beavers, because they were buffered against the drought, because they were able to store that floodwater during our wet periods. They've just sort of delayed everything and taken everything down a notch, and the plants are literally too wet, too green, too healthy to burn. And this is not just something that like I throw together in a conceptual model and I'm like, trust me. This is something that we've seen. So these photos are from my colleague, Dr. Joe Wheaton at Utah State University. And they're from the Sharps Fire, which burned in Idaho back in 2018. On our left, we've got that stream without beavers. On the right is our stream with beavers. On the left, you can see the Sharps Fire burned down that hill slope, went straight through the valley bottom, through the riverscape, through the river corridor in many places, and then burned right up the other side completely unimpeded. Those little white blotches that you see are ash piles where we used to have riparian vegetation that has been completely incinerated. On the right, however, where we had the beavers, the hill slopes are the same. Fire came down the hill slopes. Beavers can barely waddle up and down their own dams. They're not going to be hiking up the hill slopes to do things up there. But once you're down in the valley bottom, which is within the beaver's sphere of influence, it is not burning. The fire approached the edge of that floodplain, and it could not burn that vegetation, and so it stalls. And unfortunately, many of these fires are strong enough that there's plenty of wind being generated to blow embers across a riparian zone like this. So we did see fire go up the other side, but where the beavers had engineered was protected. When you look at this more closely, it's really apparent exactly how the beavers have influenced this site. So on our left again is the stream without beavers. And I chose this image for a couple reasons. One, we had complete habitat loss here. There was no vegetation left in many parts of this river. And all of those white piles, like I said, that's ash piles. This is highly destructive. This is the kind of burning that you don't expect in a river bottom. They shouldn't be this vulnerable to drought. They shouldn't be this vulnerable to fire. And yet they are. And it wasn't enough that this was a little bit wiggly. Like, this is not as simple as the stream I drew in my model, but this is still too simple of a stream. This does not have the ability to store water during our flood periods, and so it becomes vulnerable during our dry periods. In our stream with beavers, though, you see that beaver dam channel spanning in sort of the center right-hand side of the image. It's got that larger dark pond behind it. We have those canals reflecting sunlight back up at the drones, and you can see the greenness is exactly correlated with where we have the beavers doing their engineering. The more beaver influence there is in a place, the more of that water that has been spread out to a place, the greener it is. And it's not that the fire did not try to burn in here. If you look in the bottom right-hand side of that with beavers image, you'll see there was one willow that got burnt. And it's a little pile of ash there. But after that, there's not much. So we get a little bit of singeing on the edges of these beaver wetlands, but the core remains unburned. And this is something that we're seeing over and over again. So those photos before were from the Sharps Fire in Idaho back in 2018. This photo is from Charlie Erdman with Trout Unlimited from the Bootleg Fire in Oregon in 2021. Another very stark example of an entire forest being decimated, river corridor being decimated, except where we have beavers engineering. And so this is something that I've studied directly, and I've asked, okay, do beavers keep these riparian ecosystems green during fire consistently, or is this something that is pretty rare? And to answer that question, I started off by looking at 5 fires in the American West. And at the time of this study, I thought these were all pretty big fires. I don't think that anymore. I'll come back to that. But they were good-sized fires, and there was a lot of beavers within these different fire perimeters. and a lot of variability as well between these different landscapes. So we have shrubland, we have scrubland, we have pine forest, we have very rocky places. There's so much going on here that really the only things that are consistent is the fact that it burned and the fact that there are beavers. So what I'm thinking is if I see this happening in all these different settings, then beavers are really good at making these fireproof patches or fire refugia. And if it only happens in some of these settings, then I can figure out when and where we can rely on beavers and when and where we cannot. So before I show you my data, I want to just briefly touch on how I collected it. I want you to imagine that you're walking through all of the different creeks in my study areas from a designated starting point to a designated stopping point. And you're going to do this for every creek before the fire and again right after the fire. And as you walk, you take notes about how green are the plants. Are they healthy? Are they alive? Or are they burnt? And is there any sign of beaver here? Are there beaver dams, beaver ponds, beaver canals, beaver sticks, things like that? That's basically what we did, except we used remote sensing. So we used high resolution imagery to go back in time and map out all of the beaver dams that were present at the time of the fire. And then we used remote sensing as well to go back in time and get the plant greenness along the river corridor. So we extracted pixel values of greenness as you walk along that river. And I'm going to show you some of my data from the Mantor Fire, which burned in Sequoia National Forest back in 2000. It was 79,000 acre fire, pretty big fire. Minor spoiler on this slide, that is me standing in front of a beaver dam in Sequoia in this fire perimeter, but I was not there in 2000. That is definitely not a picture of me back in 2000 when I was a child. So the beavers are at least there today, but that does not mean that they were there and they were okay during the fire. I also really like this site because it's a testament to the power of beaver engineering in difficult environments. So Sequoia National Forest, beautiful place. This is specifically in the Domeland Wilderness, which is called that because of huge granite domes that just pop out of the earth. It's very rocky. It's very low vegetation outside of your river corridors. It's very dry. It's extremely hot in the summer and extremely cold in the winter. Tough spot to live. Huge beaver complexes up there, absolutely enormous. It's hard to really get a sense of scale, even with the scale bar on the satellite image. But for reference, that beaver lodge that I've circled in the middle, that is 60 feet across, 60. That's a big beaver lodge. And in California housing prices, that's at least $1 million beaver lodge. So they've really done some good work up here. That makes me feel a little bit confident for them going into this fire. But it was a serious fire. This is a quote from the LA Times about the Mantor Fire that really speaks to just how intense it was. It is a humbling expression of nature, walls of flame 70 feet high, twice as high as the nearest tree, leaping through canyons and valleys, at times in 5 directions at once. Left behind, quite literally, is scorched earth. So the Mantor Fire is a big deal. The Mantor Fire was really severe, and even though beavers are large, 70, 80-pound rodents, they're not 70 feet high like these flames are, and they're not fast, whereas these flames can leap through canyons and valleys. So this should challenge the beavers. Let's see what the data says. So on this plot, our x-axis along the bottom, that is our distance along the creek profile. So 0 is like your designated starting point, and then you walk, 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 and then 4,000, your designated stopping point along the creek. Our y-axis, this is NDVI, Normalized Difference Vegetation Index, a measure of plant greenness or health. Lower number means less or fewer green plants. Higher number means more green plants. Before the fire, our plant data looked like this, which I am the first person to acknowledge means nothing if you don't use this measure all the time. So I put a threshold on here that's important. This dashed line is at 0.3, and that is the minimum value of NDVI that we would expect from healthy riparian vegetation during the growing season. And you can see for the most part, our plant greenness levels are above this threshold. NDVI only goes from 0 to 1, 1 being like you're in the greenest, darkest, thickest jungle you've ever been in. So seeing an NDVI of 0.35, of 0.4, that is a healthy riparian zone. You'll note that there are a couple places that are below that threshold. I can zoom in on those pixels and see what's going on. And in all of these situations, it's just a very rocky area. And so there's not as many plants present, which does artificially lower our NDVI or our plant greenness. So this was before the fire. This was after the fire. And you can see for a while, they're pretty much on top of one another. Those curves are the same. And then it drops off right around 1,500 meters Long Creek, and it stays below the threshold the entire rest of the time. we saw a loss of plant greenness. And given the context of the study, we saw burning. We saw a lot of burning of that vegetation. But what's really interesting is putting on the locations of our beaver dams on the x-axis with little black boxes. So those beaver dams, where they were present, the difference between our before fire greenness and our after fire greenness were generally not statistically significant. When we were outside of the beaver dammed areas, it was completely below that healthy plant threshold the entire time. And to make those differences a little bit more clear, I've now flipped things around and I've plotted the difference. And what you can see here is that the beaver dams are suppressing the effect of our wildfire. So a lower number means the fire had less of an effect on this landscape. A higher number means that the fire had more effect or there was more burning. And in our beaver dammed area, there was essentially no wildfire effect, despite the fact that we had walls of flame 70 feet high, twice the size of the nearest tree, despite the fact that it leapt through canyons and valleys at times in 5 directions at once, these beaver dams maintained the greenness around them. And this happened in every single study area I looked at. I was expecting to find specific conditions under which beavers can do this, and instead what I found was that beaver dammed areas are staying green consistently during wildfire across the western US. And I was talking about this with the Forest Service pretty early on in this research, and I mentioned I was looking at the Mantor fire, and someone from the call had actually been on the burned area emergency response team for the Mantor fire, and was like, "You won't believe what we took all these photos of from the airplanes and helicopters." And I was like, "What?" And he's like, "It's beaver dams." Because when they were flying over this back in 2000, they kept noting all these green points and noting that there was just something consistent about them and that they had beaver dams in them. And so that's what this photo is. It's actually from the Mantor fire. And you can see the beaver dam on the left-hand side ponding some water. You can see just how severe this fire was. It's burning soil. It's burning very rocky and mineral-rich soil and still finding enough to burn, leaving behind just these massive swaths of absolute destruction. And you can see a tributary stream that didn't have beavers on it that has absolutely no vegetation left nearby. And this was what I was seeing everywhere. The beaver dammed areas were burning 3 times less intensely than the places within the rivers that did not have any beavers present. So this was great and felt a little bit like we'd solved the wildfire crisis when I finished this study, and was quickly humbled because we are now in the age of megafires. Even here, wherever you are, it does not matter. Megafires in the last 5 years have exploded around the world, around the West, around the continent. Megafires are fires that have a burn area of larger than 100,000 acres. And just being big doesn't make a fire bad, and fire is often not bad. I want to be very clear about that. Most of our ecosystems have evolved with some sort of a natural fire regime. What's challenging, though, is when fires are burning well outside their natural fire regimes in a way that leads to very extreme and self-sustaining behaviors. So, for example, once these fires get ripping, they create their own weather systems, including things called pyrocumulus clouds. These are ember and ash spewing clouds so it looks like a thunderstorm cloud or a rain cloud, but instead of rain coming down, it rains down embers and ash, and that starts little secondary fires that merge with your primary fire. And then you can create a pyrocumulonimbus cloud, the fire-breathing dragons of clouds. These are responsible for making what we see oftentimes in viral videos on the news, like fire tornadoes and firestorms. And we haven't figured out how to deal with normal tornadoes, so we certainly don't know how to deal with fire tornadoes. When we have this really extreme fire behavior, it leads to explosive spread rates. We've seen 100,000 acres in a single day. That is far faster than we can keep up with. That is faster than we can contain. That is truly out of control fire. And when it burns that fast, it's also burning extremely hot, and that leaves behind these huge swaths of moderate and severe burning. Faster growing fires tend to be much more destructive, and that's what we're seeing. Instead of little sprinkles of moderate and severe here and there, which you'd like, that's called pyrodiversity or fire mosaic, it's good. Instead, what we see is like 50,000 acres of severe burning altogether, and that's not good. That's habitat destroying fire. So I decided to ask the question next of, do these beaver-created fire refugia persist even through this really extreme fire behavior that we're seeing? And to answer that question, I decided to look in the Rocky Mountains. They had 3 megafires burn in Colorado and Wyoming in 2020. And I mean, this is a burn severity map. Red is high severity. You don't need to bother with the other colors because they aren't there. It was just a really high severe fire. The Mullen fire, the one on the northmost side, it had about 900 satellite visible beaver dams within it. Cameron Peak in the middle had 99, and then East Troublesome had about 500. So I decided to pick these fires because they hadn't had mega fires like this in about 100 years. So this is a landscape where this kind of large fire is new, it's novel, there's not old burn scars for it to be running into. There's a lot of beavers here. We're looking at like 1,500 beaver dams that I can look at and figure out exactly when are the beavers creating fire refugia, when are they not, what conditions lead to this, which ones don't. And the data was really high resolution, and I had good coverage with satellite, which is always helpful. So I wanted to go through all these fires and look at all the different beaver dams and see, did they maintain their green landscape? And I want to say I wanted to see that, and we can see that pretty easily. So this is one of the creeks in the Mullen Fire. If you look at satellite images of beaver dams all day like me, you've already found them. If not, just wait till the landscape burns. It's really easy then because the only greenness surrounds these beaver ponds. We could see that. It took me like a day to see that in my research, and that's too fast and not enough for a research study. So we also went through and calculated the burn severity at every pixel in this landscape and correlated it with the positions of beaver dams and beaver ponds and beaver canals to say exactly quantitatively how high of severity burning did we have outside of our river corridors, inside the river corridors, but where we did not have beavers, or inside the river corridors where we did have beavers. And once again, I was surprised by just how consistent the beavers were. So these are color-coded by if it's fire refugia or not. Fire refugia is color-coded blue. That is low severity burning or unburnt. This is good for the landscape. Generally, this is easy. This does not kill plants and animals in a big way. Red is moderate and high severity. That's fine in small sprinkles, but when we have a lot of it, that is typically not particularly good for your landscape and can take a really long time to recover from. In our non-river areas, 60% of the landscape was not fire refugia. So that's a much lower, or sorry, that's a much higher number than we would expect. Our fire refugia was much lower than we would expect. These were very, very destructive fires. That's not unexpected here, given that context, but it is unexpected given, what Colorado's natural fire regime should look like. One would hope that the rivers without beavers would be better, but they were not. So they were about 50-50 if it was going to be fire refugia or not. This is concerning to me because rivers should be wet, rivers should be relatively fire resistant, and yet we're seeing them behave in a fire context just like the hill slopes, which are totally dependent on precipitation and existing groundwater. They're not the hydrologic features. Why are our rivers not acting like hydrologic features? Well, the good news was they do, as long as there's beavers there. So when we had beavers in the river, 89% of that was fire refugia, 11% of that area was not fire refugia. I did look at that 11% because I was like, aha, I figured out when this does not happen. Almost entirely, I actually didn't answer that question because what those pieces were that were at moderate and high severity, that was the very edges of our beaver ponds. So it's where you get that little bit of singeing around the edge, a little bit of burning as it starts to approach into the wetland, but the wetland cores were still completely unburnt. And so we are still seeing this strong refugia effect. I saw a small handful of cases where the beaver ponds did actually burn. And in those cases, what I determined looking through the satellite imagery archive was that those beaver ponds were very, very new. Like they had been built that year. And so they did not have time to store water. They did not have time to dig their canals. This was like a brand new pond. And then the fire hit. And so there just wasn't that hydrologic stability built in yet. They hadn't gone through the full cycle of store the water, protect against drought, stay healthy during fire. They kind of jumped in right in the middle. So we did see about 5 ponds lost to this fire, but out of 1,500, that's still a pretty good rate. And these patches are really important. This is the view you'd have from inside one of these beaver ponds during a wildfire right after it comes through. The vegetation is green and lush. There's plenty of it. The water is cool. It's clear. It's flowing. There's fish. There's bugs. There's all sorts of things. Just a little ways away, there's total destruction of the forest. Those trees are burnt roots to tip. There's holes in the ground where their roots used to be, and it's just ash now. But the beaver wetland itself is fine. This is a bank of plants. This is a bank of animals. This is a bank of healthy soil. And this is there keeping things intact. And then after the fire, what we suspect is that these patches are really important for helping larger scale landscape recovery. We have the mature trees to put their seeds back out. We have a place where animals were able to survive through the most intense part of the disaster and then venture back out on their own afterwards. These are important patches. And it's important financially too. It's not always the best thing to put a dollar sign on an animal's value, but at least with beavers, it can help bridge the gap between policies and funding and science and implementation. So this paper from back in 2020 did a really good job of just estimating the value of the different ecosystem services provided by beavers. And I will say, this does not actually include wildfire. This, when they talk about moderation of extreme events, they're just talking flood and drought. So add some money to this when you think about the fire benefits. But even so, it's a lot of money. $179,000 per square mile per year of benefits provided by these beavers. That's a lot. Like normally that's what we're paying engineers to do, to give us all of these things that we want. But instead of having to pay somebody, the beavers are just doing it. And I'm not saying we should put engineers out of business. I wouldn't want that either. But we can be more strategic. We can let the beavers engineer the riverscapes, work with them, support them in that. And then we can put our engineering and our big brains on the hill slopes and at the places the beavers do not affect and that they are not in control of. And working together, that does seem to me to be the most prudent path forwards for actually building landscape scale climate resilience. Protecting our riverscapes, that's protecting like the lifeblood of the landscape. But working alongside beavers and coexisting with them and being strategic with them, that's where we truly can see much larger basin and watershed scale protection. So I know that was a lot of information really fast. And I could probably talk about beavers for about 100 more years, but that's not the point of today. So I'm happy to answer any questions that you all have right now. And if we don't get to them, you can also always email me or check out my website where I do keep some interesting beaver information stored in the meantime. So thanks, everybody. And I'm happy to take your questions.
Thank you.
And I'm
so
going to
much.
open up. I'm going to
Sorry.
open up questions to all of our speakers for this morning, because this is our last question answer bank.
While we're waiting for folks to think of questions and get the courage to put their hands up, I've got a question for you. So did you come across any situations where maybe in a low severity fire that these systems actually prevented the spread of fire across the landscape, not just having refugia in those wetter areas?
Yeah. So we did see, I've seen a few examples of that in my own research. The first was in a fire that didn't make it into my study because I had too much cloud cover to look at most of it, but I did have a section that I was looking at, super huge beaver wetlands, like about 1 kilometer wide of beaver engineering, absolutely massive. And that did function as a fire break during a large fire. That was like, wow, okay, so they can do this. In smaller fires, we've seen this happen in the Methow Valley, where the fire has approached a beaver wetland that is a longer string of wetlands and has been unable to get through it. When they're not making their own wind and weather, it tends to be more reliable to have that effect happen. We've seen structure protection in other places where even if they're not completely stopping the fire, strategic shaping of the beaver wetlands has protected lodges, cabins, things like that from burning. And then finally, we've seen people work successfully with the beavers in Nevada and in Washington, where the hotshots will drop in and then they'll do backburns off of the beaver wetland to increase the width of that inflammable area so that it actually can function as a fire break. These big fires need big fire breaks. Even small fires, you don't want to like goof around and not make it big enough. So using them strategically in our own fire mitigation has been successful in the past. I think if we had more beaver and wider beaver impoundments generally, we could expect to see this kind of thing happen more. I'll also note, and then I'll stop talking about this question, that when all these big fires start, they start small. Like it starts with a campfire or a match or a lightning strike or something small. And it gets to be a problem when that little small start can just rip for a day without anything in its way. And so more broad implementation of beavers and beaver-based restoration makes like little speed bumps all over the landscape. So you do have these starts, but maybe you never get to see if they act as a full fire break because it just tries to go and then hits a beaver wetland and it's done. We don't even notice a fire started.
Yeah, I was curious about as well, you know, more and more we're kind of using fire as a nature-based tool to restore some of these fire dynamic systems, and just, you know, interesting to think about like pairing those fire, you know, restoration actions with beaver restoration actions and kind of seeing like a landscape scale restoration project in effect. That's really cool.
Yeah, and the Tule River Tribe and the Yurok Tribe have both been really proactive of using cultural burning with beaver as complementary strategies in California.
Yeah, great. Looks like there's some questions maybe or comments in the chat box. So, Britt, did you want to monitor those.
Sorry, working across 3 screens, so it takes me a minute to find my mouse. Just 2 comments. Quantification of the dollar value of the ecosystem services should be powerful support in the efforts to get better for protection for beavers on public lands. And firefighters targeting beaver areas to work from in order to expand the fire barrier is really cool. And like I said, we've opened up questions if you thought of anything from one of our earlier speakers this morning. You know, we threw a lot of information at folks in a very short amount of time. Okay, well, if folks are a little overwhelmed, then we'll go ahead and I'll just give a couple of quick instructions. First, thank you very much to all of our, I'll pause that and go to a question from Zachary. Have you seen beavers expand more rapidly after fires?
That's a great question, and it's very context dependent. So oftentimes what fire can do is get some of the conifers and pine trees out of the riparian zone and make space for the deciduous hardwoods, the aspen, the willows, the cottonwoods to come back in. So for example, up in the pine forests in like the Pacific Northwest, but also in Minnesota and also in Alaska, some of the things that we've seen is when fire comes through, into beaver places that do not have beavers currently, and it takes down a bunch of that canopy of the coniferous and pine forest. Those preferred food species come back, and then the beavers in the system do go seek out some of those burned areas because now all of their favorite food is growing in nice and fresh. That's not going to be the case when you have complete like ecosystem destroying fire, like in some of those photos I showed where it's just like wiped down to nothing but mineral ash. That takes a really long time to recover from, and there's not going to be as much food. And if the beavers have preserved food around themselves, they're not going to bolt. So yeah, context dependent, and how severe the fire was really matters, because if you've destroyed your seed bank and the food's not coming back, then the beavers won't want to go there. But if you've just cleared it out and let the riparians come back, then they will want to go there.
Yeah, that was a really interesting question. He says, thank you. So I wanted to give a round of applause for our speakers. Thank you very much for giving your time and expertise. And yeah, I think that we'll be making sure to include your contact information in the resource packet. And so you'll probably be getting a fair amount of questions in the between now and the workshop, and then maybe after some of the field days. Oh, here's another longer question. I'm curious if people know if the efforts to change the protections on beavers have been successful. I've lost track of what actions were successful. I recall that ODFW was asked to change how trapping on public lands is allowed, and I recall an effort to change their classification as an agricultural pest, but I don't remember what the end result was. And I think that's Oregon specific.
I testified on those bills, so I can give a little bit of comment on it. My understanding is that the current state is that beavers are now going to be managed as a fur bearer on public lands instead of as an agricultural pest. It does not stop people from getting permits for trapping or anything like that, but what it does do is actually requires the permit for trapping. And so for a while in Oregon, one of the big issues was they just had absolutely no way of knowing changes in their beaver population because there was no tracking the beavers lost to trapping. So now, at least on public lands, they'll be able to get an idea of how many beavers are being taken on and off, and they are supposed to be managed a little bit more prudently as a fur bearer. So serious conflict should be demonstrated before trapping occurs. It's not just a willy-nilly trap when you want to trap situation. It's very complicated up there, having beavers managed in so many different ways and all the different considerations, all the interested parties and the wolves and the rangers and the whole thing. But it's moving in the right direction, and beavers are now better poised to be protected in Oregon than they were before these bills.
Oh yeah, that's Sounds very complicated. Says, thanks for the clarification. Glad to hear it moving forward in a positive way. Great. I'll go ahead and let you guys out a little early today, especially because we're going to be back here same time. We'll have much more of an architectural and design conversation tomorrow. If you can't make that, remember to view the recording, which will be posted. I can't necessarily say when because we have to download it and then upload it, which sometimes can take a while. But as soon as possible after the webinar, I'll be doing the same thing with the recording today. So again, I want to say thank you to our speakers. And you'll be hearing from us shortly. And I'll see everyone else tomorrow. Thank you very much. I'm going to go ahead and start the recording.
Thanks,
Thank
everyone.
you. Bye-bye.
Thank you.